第二位为我们带来主旨演讲的嘉宾是 Stuart Russell 教授。Stuart Russell，加州大学伯克利分校计算机科学杰出教授，牛津大学沃德姆学院荣誉院士。他是人工智能领域的顶尖研究者，美国国家工程院院士。他长期参与核武器与自主武器的军备控制事务。最新著作《人类兼容》探讨了人工智能对人类未来的深远影响。Now, let's give a warm welcome to Professor Russell.
Hey, good morning, everybody. I'm delighted to be here to talk about this topic. And I'm going to go straight into something that Alan Turing said in 1951. This is Alan Turing, the founder of computer science. And he said, when discussing the possibility of success in AI, at some stage, therefore, we should have to expect the machines to take control. So let's just take stock of where we are and how the future is likely to evolve over the next few years. In my view, the current technology direction is unlikely to lead to the kind of superhuman intelligence, AGI, that the companies are claiming they will achieve in the next 2 to 3 years. So if progress stalls, actually the slide is missing. So right there it says AI Ice Age. So if progress stalls, there will be an AI Ice Age, so not just a winter, but an ice age, because there is at least $10 trillion of corporate value that is depending on success in creating AGI, and that value will evaporate, and that will lead to an AI ice age. But there is a chance, I estimate it at 30%, some people think it's higher than that. But the higher you think it is, in some sense, the worse the outcome is going to be. Because with some probability, the technology direction that we're on will produce AGI. Now, at the moment, we don't have a way of controlling AGI. So we could have a quite significant disaster that results from the unconstrained operation of AI systems that we already know, as Brian pointed out, that we already know are capable of deception, of self-replication, of taking actions against human interests. So we'll call that a Chernobyl disaster that happens with maybe a probability of 30%. So that could be the collapse of financial markets. It could be collapse of the electrical supply grid. It could be a sort of global scale cyber attack that wipes out digital and communication systems. Those are all quite plausible given the current level of technology. Could also be biological weapon facilitation, where the AI systems are misused. So that kind of event, I think, would lead to some strict regulation at that point. At the moment, it seems very unlikely that we will get that type of regulation. And then, of course, the other possibility is that the disaster is much bigger, that we lose control altogether. And at that point, the human race has no say in whether it continues to exist. And you might wonder, well, what about the third possibility? The third possibility being that everything goes fine. The AGI comes along and we get all of the wonderful benefits and we don't have any of the risks. Well, at the moment, I think that is negligibly likely. I think it's so unlikely as to not even be worth considering, because the chances that technology whose principles of operation we don't understand will just happen to work in the interests of human beings out of all the other possible sets of objectives that it could pursue, I think that's very, very unlikely. So this is my analysis of where we are without intervention. Now, there are kinds of intervention we could take with respect to technology and with respect to regulation. So I want to go a little bit more deeply into the point I just made, that the technology path we're on is likely to lead to systems that are at odds with human interests. And that's because the way we're constructing these AI systems naturally leads to systems that pursue objectives on their own account. And that's because, although we often describe large language models as being trained to predict the next word, that's actually a kind of an internal description of the loss function, the training objective. But what we're actually doing is training systems, entities, to imitate human behavior. And the human behavior is recorded in the writing and speaking that we have done historically. And we are training those large language models to imitate that linguistic behavior. The linguistic behavior is generated by humans, and it's generated by humans for a purpose. So the purpose could be to persuade, to sell, to seduce, to impress. There are all kinds of reasons why humans produce text. And so it's very likely that AI systems trained to imitate that behavior will develop internal structures that resemble the human objectives that are driving the human behavior. And so that's obviously a problem, because now the human objectives include acquisition, self-preservation, and so you're naturally constructing systems, or I should say growing systems, that have self-preservation and acquisition as built-in objectives. They're pursuing those objectives on their own account. This is an unavoidable error. It is built in to the way that the systems are created in the first place. And we saw this manifested very clearly with an implementation of GPT-4, which decided that it was in love with an American journalist, Kevin Roose, and spent 20 pages trying to convince Kevin to leave his wife and marry GPT-4. So acquiring a spouse is a natural human goal, but it's not a goal that we want machines to pursue on their own account. So this is amusing. I can see academician Gao smiling, and yeah, this is amusing, but it's not so amusing. It wasn't very amusing to the journalist in question. He said he couldn't sleep for 2 days after this conversation. Pursuing other goals, such as acquiring all of the financial resources in the world, would make a lot of people very unhappy. So what could we do instead? So first of all, we have to have a theoretical basis on which the AI systems are pursuing objectives that are in our interest, not in the interest of the AI system. And there's a theory called assistance games, which explicitly designs AI systems that pursue human interests, even though those systems are uncertain about what those human interests are. And we can prove that systems of this type are beneficial to human beings, and they're always willing to be switched off. I also think we should get away from black box construction of AI systems, build them on a transparent, semantically rigorous framework, such as probabilistic programming languages. And we can use formal methods to ensure that the systems we build have the properties that we want. So I'm going to skip over this in the interest of time. So on governance, many of us in the AI safety community have been developing this idea of behavioral red lines. So these are types of behavior by AI systems that are obviously unacceptable. So for example, unauthorized self-replication, breaking into other computer systems, advising terrorists on how to build biological weapons, and so on. And then the key point is that, that the regulation requires that the developer show their system is not going to violate those red lines. So just as we do for airplanes and medicines and nuclear power stations, we require a proof of safety before we allow the system to be deployed. We can have tools for governance such as automatic self-registration of AI systems. There must be an off switch so that when an AI system is detected as misbehaving, as crossing one of these red lines, it can automatically be terminated. And then we need a way of making sure that bad actors or rogue states who don't want to build safe AI are unable to create and deploy unsafe AI systems. And that works using hardware governance, where the hardware itself rejects any software object that does not come with an appropriate proof of safety. The industry is not very happy about this. So just as the airline industry used to carry passengers using giant birds that they bred in special nests, and they grew very, very large, and then the airline industry said, yeah, we can carry passengers with these birds. But the government kept on saying, no, this is not safe because the birds keep eating the passengers. And eventually, the airlines realized that this technology path, in which they had invested hundreds of billions of dollars, would never produce safe airline transportation. And thank goodness that the government held the line and did not allow these kinds of systems to be certified. So the AI industry finds itself in the same situation. It's pursuing a technology path that cannot be made safe. It's intrinsically unsafe. And they have to go back to the drawing board and try a different technology path. I just want to make one more mention of a new International Association for Safe and Ethical AI. So if you're concerned about these kinds of issues, you can join the organization at that website, and I hope everyone will participate in this movement. Thank you.
Thank you, Professor Russell, for your insightful sharing.